everyone. Today in this lecture we will learn a new unit of concentration of a solution, that is molarity. It is a new unit to measure the concentration of a solution, and molarity of a solution is denoted by capital M. It is defined as the number of moles of a solute that should be present in 1 liter of solution. Molarity means the number of moles of solute that should be present in 1 liter of solution, and mathematically it is calculated as M is equal to number of moles of the solute upon volume of the solution in liter. As the number of moles of solute are represented by N, so we write M is equal to N upon V in liter. One more thing, how do we find the number of moles of the solute? For number of moles of the solute, we can find the number of moles of the solute is given mass divided by molecular mass, that is N is equal to W by M, where W is the given mass of the solute and M is the molecular mass of the solute. When we put the value of N, that is W by M, in this equation, then the formula of molarity becomes, the value of N is W by M. I write here W by M upon V in liters. So it becomes M is equal to W by M upon V, or it is written as W upon M into V. As this M and M are same, so I write here MM is the molecular mass of the solute, so that we can differentiate this M, that is molarity, and the molecular mass. So I write here volume in liters. If in a given solution volume is in milliliter, then we have to divide volume by 1000 so that it should be in liters. If volume of the solution is in milliliter, then its formula is W upon MM. As volume is in milliliter, so we have to divide volume by 1000 so that it should be in liters. As it is in the denominator, when you solve this, it comes on the numerator, and its formula becomes M is equal to W upon MM into V multiplied by 1000. This is the mathematical derivation to solve the molarity of a given solution. Here m is the molarity of the solution, W is the mass of the solute, mm is the molecular mass of the solute, V is volume in milliliter. As it is in milliliter, so we have to multiply it by 1000 so that it should be in liters. See the one numerical related to this concept. Question is, find the molarity of sodium hydroxide solution which is prepared by dissolving 4 grams of sodium hydroxide in 100 ml of solution. Question is, find the molarity of sodium hydroxide solution which is prepared by dissolving 4 grams of sodium hydroxide in 100 ml of solution. Here the mass of the solute is given to you, that is 4 gram. Also the volume of the solution is given to you, that is 100. As we know that the formula for calculation of molarity is mass of the solute divided by its molecular mass multiplied by 100 into 1000. In this question, W is given to you, that is 4 grams. Molecular mass of the sodium hydroxide you have to calculate by this formula, and it comes out to be 23 plus 16 plus 1, that is 40 grams. And volume of the solution is also given to you, that is 100 ml. Put all these values in this formula and you will get the value of molarity, that is m is equal to 4 upon 40 into 100 multiplied by 1000. It comes out to be 1 or 1 molar solution. Hence the molarity of the solution which is prepared by dissolving 4 grams of sodium hydroxide in 100 ml of solution is 1 molar. This is a new unit to measure the concentration of the solution. Our next unit to measure the concentration of the solution is molality. The next unit to measure the concentration of the solution is molality, and it is represented by small m. The molality of the solution is represented by small m, and it is defined as the number of moles of solute that should be present in 1 kilogram of solvent. The molality of the solution is defined as the number of moles of the solute that should be present in 1 kilogram of the solvent. In case of the molarity, here we take the volume of the solution, that is in liters or 1 liter of the solution. In case of the molality, instead of the solution, we take the solvent or mass of the solvent. And the mathematical derivation for the molality is number of moles, that is N, upon mass of the solvent, that is in kilograms. Now, as we know that the number of moles can be found by W upon mm into mass of the solvent. Here W is the given mass of the solute, mm is its molecular mass, and this is mass of the solvent, that should be in kilograms. This is the mathematical formula for calculating the molality of a given solution. See one numerical related to this concept or the molality. Find the molality of the solution of sulfuric acid prepared by dissolving 9.8 grams of it in 200 grams of water. Question is, find the molality of the solution of sulfuric acid that is prepared by dissolving 9.8 grams of it in 200 grams of water. Here water is a solvent and sulfuric acid is solute. In this, the mass of solute, that is 9.8 gram, is given to you. Also the mass of solvent, that is water, is also given to you. So put the formula, that is molarity of the solution is equal to W by mm into mass of the solvent in kilograms. Here W is the given mass of the solute, that is 9.8 gram. But the molecular mass, you have to calculate the molecular mass from the formula of the sulfuric acid. The molecular formula of the sulfuric acid is H2SO4 and its molecular mass is 1 into 2 plus 32 plus 16 into 4. Here 1 is the atomic mass of the hydrogen, 2 are the number of the hydrogen atoms, 32 is the mass of sulfur, 16 is the mass of oxygen, and 4 are the number of atoms of the oxygen. When you add these, you get 98 grams. The molecular mass of the sulfuric acid is 98 grams. Put these value in this formula. Molality of the sulfuric acid solution is W is 9.8. Molecular mass of the sulfuric acid is 98 and the mass of the solvent is 200 grams. As we need the mass of the solvent in kilograms, so we have to divide this 200 by 1000 so that it converts into kilogram. Just solve this. 9.8 divided by 98 multiplied by 200 into 1000. it comes out to be 1 by 2 or 0.5 molar. Hence, the molality of the solution, which is prepared by dissolving 9.8 gram of sulfuric acid in 200 grams of water, is 0.5 molar. These two are the new units to measure the concentration of a given solution, that are molarity and molality. Thank you.